Hello, hello. Welcome to Unacademy. I am Sunil Manjani. Uh, First session. Okay. Once again, I will welcome you to Unacademy, and this is India's largest learning platform. Okay. So before starting our session on Matlab, let me introduce myself. I am Sunil S. Manjani. I have 15 years of teaching experience, mentors thousands of students for GATE ESE semester exam, cracked PSU exams like GATE, HAL, MARDISCOM, MAHAJINCO, etc. Okay. So this is brief about myself. Okay. How to get an academy subscription? Okay. How to use the application? Step one: go to Play Store or Google Play Store or App Store, and type in Unacademy. Unacademy learning app will be there with this symbol. You can see. Okay. Click on this. In step two, you will be prompted to install the application. Okay. So So in step 3, after installing the application, you go to manage goals. Okay, gate and ESC. Click on gate and ESC. Step 4, click on the subscription type. Suppose you're clicking on plus. Okay, then you will go to step number 5. You will get a button of get subscription. Okay, so press on that button. Okay, so after that, you will be prompted to select your plus is already selected. So in plus subscription there are 1 month, 3 months, 6 months, 12 months, 18 months and 24 months plan. 12 months plan will cost you 27,225. 24 months plan will cost you 39,600. Okay, you can get a further discount of 10% if you use my code SSM10. Okay, you can also use iconic plan, that is it will have 12 months subscription of 45,225 and 24 subscription amount of 24 months subscription amount of 66,600. Okay, you can get again further 10% discount on SSM10 using that code. Okay, plus subscription will give you India's best educator. It will give you interactive live classes, structured courses and PDF, live tests and quizzes. All this are the features of plus course. Iconic course will have all the features of plus course, all these features plus more advantages to select the iconic course. Okay, you can also select plus course or plus subscription if you want. So let us see. In today's Matlab fundamentals, okay, we will cover following contents. You can see that the array operation will cover one example will cover of array operation. Okay, one array example example 2 will cover. Okay, Number display will cover display format. Okay, saving the work in Matlab. We'll see what is script file. We'll see what is script file example, and we'll cover some additional simple example using Matlab. Okay, so let us see. First of all, what is array operation example? Okay, so we'll see array operation example. Yesterday we had seen one example. Okay, so for the time being, let me see if I can. I will open the Matlab. Okay. I will open the Matlab. Okay. Just a minute. So from Matlab starter application, I will open the Matlab. Okay, what is array example 1? Okay, what is array example 1? Okay, so so we had covered wind tunnel example there. Okay, so today we'll see what is example of force, you can say. Okay. So force example we'll see. Force example we'll see. Okay. Just a minute. So force example we'll see. Example we'll see. Okay. So we'll convert force from so conversion of force from British unit to SI unit. SI. Okay. So British unit for force is pound foot. Pound foot. Okay. Pound foot. Okay. This is British unit. Okay. For three spaces. Okay. And I will write n transpose. Square bracket close. Okay. And transpose square bracket close. So I will say enter. So this is simple. You can say left side is pound and right side is Newton. This is a factor which can be multiplied to each and every value in pound as well as in Newton. Okay. So this is one example we have understood. Okay. So let us see with other example. Okay. So let us see with other example. So array operation example number 2. Okay. Just a minute. Okay. Array example. Array example 2. Let us see. Let us see array example 2. Okay. Let us see array example 2. Some issues with streaming. Okay. So let us see array example 2. This array example 2 is calculation of drag. Calculation of drag for airplanes. Airplanes. So what is the formula? Formula for drag is drag is equal to CD R into V square A divided by 2. V square A divided by 2, where see it is not of concern that you are using this mechanical engineering example or electrical engineering example. These are some simple examples. Okay. So this is drag coefficient, air density, velocity, A equal to reference area. Okay. If I say this is my airplane, this is my aircraft or airplane. Okay. These are fins. Okay. So this is the lift. This is weight of airplane. Weight of airplane. Okay. This is exhaust, also called as drag. Due to this drag, there is a thrust. There is a thrust. Okay. So this is simple example of drag. Okay. So what data I will assume? Data I will assume. Okay. Data I will assume that initial drag is equal to 20,000 Newton. Initial drag is equal to 20,000 Newton. Okay. Air density is 1 into 10 to the power minus 6 kg per meter cube. Air density is this. After that, velocity is 100 miles per hour and area is equal to 1 meter square. Area is equal to 1 meter square. Okay. So with this information, we'll go on to step 1, that is problem statement for Matlab. Problem statement for Matlab. Okay. So you will calculate drag coefficient. Okay. Second, use drag coefficient to determine different velocities. Okay. So these are two problem statements. Second is input and output. So what is input? Input is data I have given you. Input is data I have given you. What is data? Drag is equal to 20,000 Newton. R is equal to 1 into 10 raised to minus 6 meter cube. A is equal to 1 meter square. Output. Drag coefficient. Okay. Velocities. Multiple velocities from, suppose, from let 0 to 200 miles per hour. 200 miles per hour. Okay. So this is the problem statement. Okay. So third step is hand example. So what is drag coefficient? CD is equal to drag into 2. We have seen the formula. Okay. So CD is drag into 2 divided by RV square A. RV square A. Okay. So with the data, if I calculate this, I'll get CD is equal to 2.0019 e to the power 7, or you can say this is like a calculator value into 10 to the power 7. This is the drag coefficient. Okay. After calculating drag coefficient, we can calculate drag velocities. What is drag velocity? What is drag for different velocity? We need to calculate. Drag is equal to CD by 2 into RV square A. RV square A. Okay. So we'll input different velocities. Different velocities using the. So suppose for 200 miles per hour, that means velocity v equal to 200 miles per hour, drag comes out to be 80,000 Newton. Drag comes out to be 80,000 Newton. Okay. So let us see, let us define this with Matlab. Okay. So we will go with hands-on in the Matlab. Okay. First I will say CLC. Okay. Sorry, CLC. It will clear command window. Then I will say clear all. It will clear workspace. Okay. Again CLC. It will clear command window. So we are ready with new value, new program. Okay. So we will write down first data. Data. What is the data? Drag is equals to 20,000. Don't want to display, therefore semicolon. Air coefficient, okay, or rather air density is equal to 1 into 10 to the power minus 6. That means 1 into e to the power minus 6. I want to display it, so simple. 1 into e to the power minus 6. Okay. This don't write semicolon. Next one is velocity v. Velocity v is actually in data 100 miles per hour. Okay, miles per hour. Miles per hour is not SI unit. Okay, it is kmph, velocity kilometer per second or meter per second. Okay, so what I will do is I will multiply this by 0.4470. 0.4470. I will write down, converted to SI unit. Whenever I write down anything after this percentage sign, that will not be executed. So if I say V, 44.7 is the meter per second velocity. Area of reference is 1 in meter square. It is SI unit. Okay, so I will write down drag coefficient. I'll write down the program now. Drag coefficient. What is drag coefficient? What is drag coefficient? In the example we have seen, it is drag multiplied by 2 divided by, in bracket, r multiplied by 2, sorry, v square, that is v cap 2, okay, multiplied by a, bracket close. Okay, so this is CD. So if I press enter, you can see this was our answer. This was our answer. So it is verified with hand calculation. Okay, with hand calculation it is verified. Now for different velocity I need to find out drag. What are the velocities from 0 to 200? Suppose I am saying that velocity v is equal to square bracket 0 initial velocity colon, that is, suppose increment is 20 and last velocity is 200, square bracket close. This is my velocity. For this velocity I need to find out drag. Okay, but these are in miles per hour, so I need to convert this velocity into kilometer per hour. So left assignment v is equal to right assignment v. Right assignment v is nothing but initially in miles per hour multiplied by 0.4470. Rather I will say 0.4470. So if I enter, I get this. You can check with the transpose also. These are the values in which meter per second. These are values in meter per second. Okay, meter per second. So I will say this is velocity. I will need to calculate drag for this velocity. Drag is equal to, for each velocity I will calculate drag. Drag coefficient divide by, or rather in bracket, drag coefficient divide by 2, okay, into rv square a, r into v square means cap 2 into capital A. So this I will enter. Okay, now this is saying that v square raised to, sorry, cap 2 is not valid. Okay, so what I will do is, this is the, this situation we had taken care in yesterday's lecture. So what I will do is, I will put v dot cap 2, because now v is not a single value, it is an array. So we have to take a square of each term element by element. So we'll put v dot cap 2. So now I will hit enter. So I will get this drag. So you can check with the transpose. So this is your drag value. This is your drag value. This is the drag value. Okay. This is the drag value. So now what I will do is, I will put drag and velocity in one or in tabular form. So this is drag transfer. velocity transpose space drag transpose. So you can see, okay, you can also plot. You can also plot. I will say VE, or rather small VEL is equal to V, okay, and dr is equal to drag. You can also say it like this, okay, or you can straight away put a plot command between what, drag and velocity, between drag and for different velocities, okay. So for different velocity, what is the drag? So velocity will be x coordinate, drag will be y coordinate. So it is calculating, we'll wait, okay. See the figure, it will appear in the Matlab command window. Let it come. So you can see clearly x-axis is velocity and y-axis is a drag. So figure you can plot between velocity and drag. So this is my second example, okay. So clear this hands-on is clear. So let us see next topic, that is number display. Okay. So number display, so you can display constants like this in Matlab. So suppose I have got Avogadro's constant, that is equal to 6.022 e to the power 23, okay. So in Matlab you can display like this, okay. Absolute permeability is equal to 4 into pi into e to the power minus 7, okay. 4 into pi into e to the power minus 7, or simply you can write down 4 into pi e to the power minus, okay. In this way you can display the value, number display. These are what, scientific notations. Constant as in scientific notations. Scientific notations, okay. So this is number display, number display, okay. So let us see What is display format? You can see if I write down a equal to 5 and hit a enter, it will display a equal to 5 like this, or rather a equal to 5. Okay, if I write down a equal to 5.1, it will display a equal to 5.1000. Okay, if I write down a equal to 51.1, hit enter, it will display a equal to 51.1 thousand. This is 51.1 thousand. Okay, so I can increase this number of zeros by simply writing down this command. If I write down this command, format long, and press enter a, okay, a was 5, but it will, sorry, last value of a was 51.1, so it will return a is equal to 51.1 1 2 3 4 5 6 7 8 9 10 11 12 13. Like this it will return, like this it will return. Okay, now what I will do, I will write down format short. So again it will give me, if I press a and hit enter, I will get a is equal to 51.1000. So by default our display format is short. Display format is short. Okay, so this is our display format. Suppose now display format is short, our display format is short. Okay, suppose I have got a equal to 602 1 2 3 4 5 6 7 8, like this, 8 zeros. So mathematically this is same as a equal to 602 into 10 to the power 8, isn't it? Or it is also same as 6.02 into 10 to the power 10. Okay, so if I hit the enter button, okay, so I can get this as a is equal to 6.0200 e to the power plus 1, e to the power plus 1, like this. So this is one of the display format. Okay, You can also write down, suppose I want to write down format exponential format. Okay, format short exponential. So and then I input x is equal to 10.356789. 10.356789. If I press enter, I will get x is equal to 1.0357. That means 1.03. This is 1.0357 equal to plus 001. Plus 001. Okay, it is one and same thing. This will come here and it will be multiplied by 10 raised to 1, that is e raised to plus 001. 3567. Now 6 will be upgraded to 7 because this is greater than 5. Okay, so this is display format, one of the display format. Okay, so let us see. Okay, I will give you one table. Okay, so this is what format we have seen. Uh, we have seen display format. Okay, one more display format. Suppose I am writing down format plus. I will write down b is equal to some array 1 minus 5 or 1 comma minus 5 comma 0.12. Then I will write down semicolon, that is in second row. Oh sorry, this is 0 comma 12. Okay, then semicolon 1005 comma 24 comma minus 10. Okay, comma 4, like this, comma 4. So if I press enter, I will get b equal to, I will not get the values, I will get the symbol signs. This one is positive, so I will get plus. This one is negative, so I will get negative. This 0 is positive, I will get positive. This 12 is positive, I will get positive. Okay, in place of 0 I will not get anything, whether positive or negative. I will get a space. Okay, I will get a space in place of this. Okay, I will get a space. Okay, but in place of 12 I will get positive. Okay, then there is semicolon symbol, so it will go into next row. 10005 is positive, 24 is positive, 10 is minus, and 4 is positive. So I will get it like this. This is display format. Okay, so this is display format. This is some type of display format we have seen. display format. Okay, so this is display format. One more format, I will say format short. Format short. Okay, so format short, for example, it will be displayed like this. We have seen this value when we were solving some example. We have seen this value. This was the case. So this is star, that means multiply by suppose 0, 0.0002, 0.0004, 0.0006, 0.0008, like this. Let us see, this is 0, 0.0400, 0.1602, 0.3603, 0.6406, like this. That means this will be multiplied with each and every element of this column, each and every element of this column. So this is format short. Okay, so this is display format. On next we'll see what is saving variable. I hope you can understand what are the formats there. Okay, if you need a larger number, or you can say large zeros, or you want to expand the format, just write down format space long. Otherwise no need to do anything, because by default format is short. Okay, so by default format is short. Okay, so okay, suppose what is saving the work. Okay, saving the work, saving the variable. Okay, so suppose I have used script file. What is that, we'll see later. Okay, it is a m file, dot m file, matlab file, in which you can write down the program. Okay, so this is a matlab file. Okay, some program you have written down. Okay, few lines, and you have saved this file. Okay, suppose this you have saved this file as by any name, file name. Okay, so once you have saved this file, and suppose you are making the changes, then again you have to save. So you can save directly from the editor, from the icon, or you can save in the command prompt, like save command. In this triangular bracket, write down file name. Okay, then once that file, you can close that file. Suppose you want to open that file or load the file in workspace, that means you want to load the file in command prompt. So command is load in triangular bracket file name, angular bracket file name. Okay, triangular name will be file name. Okay, okay, as we have seen, if you write down clear all, what it clears, workspace. Okay, if you write down CLC, it clears command window, command window. We have seen this hands on. Okay, we have seen this hands on. Okay, so this is saving the work. Okay, we'll take one example. We'll take one example. Okay, suppose a equal to 5. Suppose a equal to 5. Okay, I write down, it will return a equal to 5. Suppose b equal to 1 space 2 space 3. Enter. It will return b equal to 1 space 2 space. Suppose c 1 space 2 semicolon 3 space 4. Enter. It will return c equal to 1 2 3 4. C equal to 1 2 3 4. Okay. So this Matlab has a capability. Okay. Matlab has a capability. Okay. Suppose all this work you are saving into one file. All this work you want to save into one file. Okay. So just write down save, write down file name, any file name you can select, but with constriction. Okay, then there will be variable list. Okay, variable list. Suppose I want to save only variable a and b, a and b. Okay, so what I will do is, what I will do here, okay, write down save. Suppose file name is ab.m, ab.m, then variable list. Again you can say, this is not a syntax, just I am writing down a space b. So how you will write down in Matlab command window? So just write down like this, save space ab.m space a space b. So it will store, it will save only variable a and b. It will say only variable a and b. So this is saving the work. Okay. I hope you are getting this point by point. I am taking it really slow. Okay. Really slow. Okay. Let us see what is script file first of all. Okay. What is script file? It is also called script M file, script M file. Okay, so we'll see this script file in a hands-on example. Okay, so we'll see script file with hands-on example. Okay, so for that, let us go to Matlab. Let us go to Matlab. Okay, all the variables are there. Okay, let us close the figure file first. Let us close this variable name TLC. Let us clear first workspace, clear all. Let us clear command window TLC. Okay, now you can see that here. Okay, if you see here, I got new script. Click on this. If I click on this, okay, I will get editor, untitled editor. This is Matlab script file. This is Matlab script file. I'll write down comment. This is Matlab script file or M file, or it is called as .m file. .m. Sometimes you need to find out, you need to name it as .mat file. .mat file. You can see here, this is script file, new, open, drop down menu, script, live script, function, live function, class, system object, basic, advanced, simulating, extension. We will see this, all this. Open, maybe whatever m file you know. Okay, you can save this, you can find files. Okay, you can insert some comments. Okay, you can debug this also, you can insert some function, you can insert some comment, you can indent it. Okay, indent, if I say I can indent it. Okay, this is first line, second line, third line, like that. Breakpoints, I can break the program into larger program into smaller parts. Okay, so I can introduce breakpoints. Okay, I can run this. Okay, run, pause on errors, pause on warning, pause if not a number, or run advanced, run section, run time. Okay, this is script file or m file or .m file. Okay, so this you can say this is my m file. Okay, .m file. Suppose now I will write down addition, matrix addition in this. I will write down the program not from second line but from third line. Let us see. A equal to matrix 1 space 2 space 3 space 4. Okay. New line 5 space 6 space 7 space 8. Let us write other example, other matrix, that is square bracket b equal to square bracket. Okay, b equal to square bracket 10 space 20, 20 space 30 space 40 50, 60, 70, 80, like this. Okay, then I will write down C, or rather capital C, equal to, I want addition of matrix. I don't want addition, is not like multiplication or division. Addition is always element by element. So A plus B. Okay, I don't want to display this A, I don't want to display this B, but I want to display C. I want to display C. Let us see. I can run this entire program. I can run this entire program. I will just comment it. This is matrix addition. I will just comment it. Okay. I will comment on this result. Okay. What I will do then? I will see here. I will save this file. I will save this file. Okay. Suppose it is asking me some location. I will select this F folder. I will select this Unacademy. Suppose Unacademy, and I will say mat add. I will save. I will not run it for the moment. Okay, let us see. Okay, I will not run it for the moment. First of all, what I will do is, in the current directory, your directory should be that where you have saved the file. So F colon is my directory. Then I will select Unacademy. I will just check whether that file has been saved or not. Let us see. F colon Unacademy. Okay. This file has not been saved yet, so we'll save once again. It is saved in F colon, directly F colon. Okay, not Unacademy. So we will see here. We will only select F colon, F drive. Okay, we will select this file. This is mat add file. We will select mat add file. Okay, I can run this file directly from the editor. If I run this file completely, okay, this file has run, and then go to command prompt. You can see C equal to 11, 22, 33, 44, 55, 60, 77. Okay, so this is the answer. Okay, what I will do is, now my file is saved. What I will do is, I will just write down the file name, MATADD, and press enter. Then also you can save it. See the workspace, there are three variables, A, B and C. A, B and, so in this way you can save this. So this is, now if I want to make some changes, I don't want to write down entire program, I want to make some changes. What change? Suppose I want to get a matrix subtraction. So this will be B minus A. I will save it. I will again run it. I will again run it. Okay, see the command window. You can see here. This is the matrix A and D. Again, next another variable has been added in the wall space, that is D. Let us see now. Okay, not this. Let us see now this one. Okay, so this is Matlab script file. Now we'll move on to our presentation. Okay, this is Matlab script file. Okay, so we'll see one script file example. Okay, one script file example. So let us see what is that example. Okay, so engine performance examination or performance study for aircraft. Aircraft. Okay, so velocity of aircraft is equal to, that is velocity is equal to 0.1234 and 1 time square, sorry, time cube minus 0.00488 time square plus 0.75795 time plus 181.356. Okay, acceleration of aircraft is equal to acceleration 3 minus 0.12344062 into velocity square. These are the equations. These are the equations. Okay. So again we will go by step. Okay. Problem statement. Problem statement is you need to find out velocity and acceleration. Second, input. What is input? Suppose starting time of start 0 seconds, final time 120 seconds, and increment from 0 to 120 0 seconds. Okay. So 0 to 1 second. So straight away we will do it in hands on. So let us see how to do it. In script file we will do. Okay. So we select new script file. So this is new script file. Okay. Command will be excuse me, calculation of velocity and acceleration of aircraft I will say calculation and plotting of velocity and acceleration for different times. Okay, so this is okay. So now you can see this command window. Okay, there are every time you will write down clear all CLC all there. Okay, so what I will do is I will write down this in Matlab script file also CLC. So every time the program runs, entire space will be cleared, command window and workspace window, and you will get a new values clearly. You can see it. Okay. So first of all, we'll define time input. So time equal to what is input? Initial value colon increment colon final value. I don't want to display it, so semicolon. Okay, so semicolon. Just a minute. Okay, time. So time is like this. This is the variation of time. Okay, what was the equation of velocity? If you remember this, velocity is equal to 0.00001 into time cube. Okay, so I will say time. Now this time is an array. You can see it is an array. First value is 0, second value is incremented by 10, that is 10, again third value is 20, fourth value is 30, like that. So what I will do is I will multiply by time cube. If I have to take cube, I will say time, okay, dot cap, that means element by element I will take the cube. Dot cap means element by element raised to power 3. Okay, all the values will be raised to power 3 for time. Okay, minus, okay, minus in bracket 0.00488. What was the, this is the equation we have seen, into time dot cap 2, that means square. Okay, dot cap square plus in bracket plus in bracket plus in bracket 0.75795 into, this is 0, into time. This is not square, into time, so don't need to multiply like dot element by element, nothing you have to do. Plus constant 181.3566. Okay, this is velocity. For the moment I don't want to display it, I can recall this one. Okay, then acceleration is equal to 3 minus, it was 0.000062 into velocity square. Okay, velocity will also be like a time vector or array, so velocity, not cap but dot cap, element by element square, element by element square. So I don't want to display. Okay, now what I will do is I want to display time, acceleration, velocity and acceleration side by side. So I will say that result equal to bracket, I want to display it in a tabular format, so I will say time transpose, then I will give a space, two spaces, then velocity transpose, again two spaces, maybe three, acceleration transpose. Remember that this acceleration spelling should be correct in all the variables. Acceleration transpose. Okay, then square bracket close, then again put a semicolon. Okay, then I want to plot, what plot? I want to plot simple plot x and y. I can have two quantities on y-axis but only one quantity on x-axis. Suppose I will say time on x-axis, comma, velocity on y-axis as well as acceleration on y-axis. Okay, so this is my complete program, simple program. I will save it, I will say velocity acceleration for aircraft. Save. Okay, so let us run it. Whether we'll also check whether there is any error in this. Okay, so let us run it. So there is error in velocity. Okay, so let us see. If I want to remove this plot command, I want to remove this plot command. Okay, or rather remove the space between plot command. So let us see, save it, again run. Let us see what is the error. I will say I will use this plot command later. Let us see. Okay. So I will say this is okay. See this file. I want to display some values. First, I will display time, velocity, acceleration, and then result. Okay. So let us see. Time. I will say time transpose. Like this, you can see. Velocity transpose. Okay. Then acceleration transpose. Like this, you will see. Okay. So I will get this type of value. Okay. Now I will say result. See time. Uh, you can see here. First is time. Second column is velocity. Third column is acceleration. Third column is acceleration. Okay. So I will say I will again. I can continue in this command window also. I will say time, comma, velocity. Okay. So if I plot this, you can see what is the value. Okay, you need to plot separately. So this is time comma velocity. Again, I can write down plot time comma acceleration. Acceleration. Okay, so you can see time comma acceleration. So let us put this two commands in the script file. Okay, let us save this and then run it. Okay, so only one figure have been displayed. Okay, we'll see how to display two figures. Okay, let us make a change. Let us save. Let us run. Let us put it last. Hold on. Let us run it. And then let us see the result. Okay. So you can get different plots also here in this. Okay. So in this way you can write down the program. So let us now come on to our PPT. Okay. So these were some of the example of script file, as well as some, you can say, example on how to plot. Okay, how to plot. So uh, we have seen some examples. Okay, some additional examples we'll see. Okay. So example 1, volume of cylinder is pi r square h. Define r as 3 and h as matrix h equal to 1 comma 5 comma 12. Okay, find volume of cylinder. This is one example. So what you will do is, h is equal to, first of all you need to define r. So you need to say r is equal to 3, h is equal to 1 comma 5 comma 12. Okay, then you need to find out volume. Volume is equal to pi, pi, small pi, star r square. This is r dot cap 2, not like that, no element by element, because it is a single value. So you can straight away write down r cap 2. Okay, r cap 2, and you can write down star h. So you will get the values. I'm giving you example. You just try hands-on for this in your home. Okay. So additional example 2. Write Matlab code for first 5 square, second 5 plus 3 divided by 5.6, third 4 plus 6 cube. For square root, remember, use the command sqrt. So for this you will write down, I will solve this here only. I will write down 5 cap 2 MATLAB expression. For this MATLAB expression will be 5 plus 3 forward slash 5.6. For this MATLAB expression will be SQRT in bracket 4 plus 6 cap 3. So this is for additional example 2. You can try it on MATLAB hands on. Okay. Additional example 3. So it is like a homework. General equation for distance that a free falling body has traveled free falling body has traveled is d equal to half gt square. Okay, assume g equal to 9.8 meter per second square. Generate table of time versus distance traveled. This is example 3. Okay, versus distance traveled. Okay. Plot between time on x-axis and distance on y-axis. Okay, this is homework. Additional example 4. Okay, generate a vector. We'll solve this in special class. Okay, maybe tomorrow we'll see. Vector containing 15 values, evenly spaced between 4 and 20. 4 and 20. Okay, last example, example 5. For current values current equal to 1 comma 1, comma 20. Find out voltage by using Ohm's law. By using Ohm's law. Okay. Take R equal to 2 ohms. Take R equal to, okay, plot between voltage on y-axis and current on x-axis. Current on x-axis. So these are example 5 examples. Okay. So these are some hands-on example you need to do. Okay. So short summary will take quickly. Okay. Symbols. This is symbol. What it does? Forms matrices, square bracket, used in statement or functions or expressions. Okay. Comma, separating matrix elements. Each element is separated by a comma or space. Semicolon, separating rows and suppressing the output. Suppressing output. If I don't want to see any variable as output, just at the end of the variable declaration I need to write down, or end of the variable I need to write down semicolon. Colon, to generate matrix. Okay, it indicates all rows and columns. Okay, equal to, this is assignment operator. Okay, percentage, this indicates comment. Scalar and array array addition. Okay, next one is scalar and array subtraction. Next one is dot scalar multiplication. dot, this is sorry star, okay, dot star array or element by element multiplication, okay, comma, scalar division dot, sorry, not comma, this is forward slash scalar division dot forward slash is array division or element by element division, okay. Cap operator is called as scalar raised to or scalar exponentiation dot cap is array exponentiation. So these are some of the commands we have used here. Okay. So let us see. Some more commands we have seen. Okay. So today I will wrap it up here. I hope you are getting my lectures quite clearly. I encourage you to please come on live. Okay.